Okay, now we're going to move on to lesson 7, which is multivalent ions. This is very much ionic bonding again. Nothing too much is going to change in regards to rules. You can still think of it as we have ionic bonding, and we're still going to have, if you recall, and I hope you do, that ionic bonding essentially is going to be a metal plus a non-metal. And, this is where you want to keep in mind the whole transferring of electrons. Metals always lose electrons, as you know, pardon me, sorry, and non-metals always gain electrons. And that's why, if you look on a table, metals always have a positive charge, whereas non-metals always have a negative charge. What we're looking at here today is just, if you look, you're going to learn here very quickly that there are some metals that actually have multiple charges. I think it would be best, though, if you do have your periodic table in front of you, and that will help you follow along with what we're trying to cover. All right, so where do you find the multivalent ions? Basically, the multivalent ions are typically found in the transition metals area, and I'm not saying that all of them are, but a great deal of them are, and that's where you're going to find these. And what you're looking at essentially is you're looking at metals that have maybe 2 charges, and if you're kind of wondering, well, which one do I take? So what we'll do is we'll work through some examples, and that they're very straightforward. But perhaps the biggest issue comes to naming, and if you don't name them properly, that's going to lead to a little bit of trouble. Anyway, we'll move on to some examples, and we'll go from there. All right, what we'll do is we're going to take, let's say, we'll take a fairly easy example. Let's look at copper. Now, copper is multivalent. Now, copper, of course, has an atomic number of 29. So, if you look at copper, I'll kind of try to draw it up here. Copper, it says 29 right there, and then it has a 2 plus and a 1 plus. So basically copper has 2 charges, and basically what's going to happen is one of them is the common charge and one of them is a little bit less common. The one on the left-hand side, the one that you would read first, that's the most common charge. So if you look here at copper, let's say we have copper and it's going to be added to, let's say, chlorine. Potentially speaking, you could have 2 different compounds formed. If you take the common charge, so let's say you have copper plus chlorine, and yes, some people might say I'm missing something. I know I'm missing something with the copper, but I'm keeping life easy right now. So the copper would have a 2 plus charge. The chlorine has a 1 minus charge. When they come together, well, how do we balance this out? We have 2 positives. We have 1 negative, so we have to have 2 negatives. So we put a subscript 2 because now everything is balanced. That's with the common charge. Now, copper has another charge. It also could be like this. Well, if we use the other one, that has a charge of 1 plus, and this has 1 minus. In this case, the charges are perfectly balanced, so this is your new compound. So I guess what I'm trying to show you here is that based on the charge that you actually use, you can get 2 different compounds. This is using the less common charge. And we will have to come down to naming here in a little bit, but for right now, I just want to show you some basic examples of how this can work out. Another example, let's go with nickel, right next to copper. So nickel is number 28, and it has 2 charges. It has a 2 plus and a 3 plus. Of course, the 2 plus is the common charge because we read that first. Let's do nickel plus oxygen. So if we use the common charge, we're going to have Ni plus O, and again, someone's going to say I'm missing a little 2 right here in the oxygen, but I'm doing that on purpose for now. So if we use the common charge of nickel, that's 2 plus. Oxygen, as you should know by now, is 2 minus. In this case, they come together perfectly. We have an even number of positive and negative charges. So this again is the common charge. Now if we use the less common charge, so we'd have nickel plus oxygen. The oxygen is not going to change, but this time the nickel has. This is one of those situations where it's a little bit more difficult to tell, and we use the least common denominator method. So this has a 3, this has a 2. Lowest common denominator is 6. 3 times 2 gives us 6. We have to have 2 nickels, and 2 times 3 and 3 oxygens. So what you can see by using the less common charge, we get one heck of a different compound. And we'll just do one more for good measure. Let's see if we can find something else here. Let's do manganese. Manganese is number 25, atomic number 25. And it actually has a charge of 2 plus and 4 plus. Let's go manganese, plus, I don't know, let's go with fluorine in this case. So if we use the common charge, that's going to be Mn plus F. Fluorine has a charge of 1 minus. Manganese, the common charge is 2 plus. That's a pretty easy one in this situation. We need to have 2 fluorines in that case to balance out. That's using the common charge. All right, now we'll use the less common charge, Mn plus F. This is 1 minus. This one's going to be 4 plus. Well, in that case, we would have to have 4 of the fluorines. Again, a much different compound. All right, so hopefully that makes sense on that situation there. Basically, you're just seeing again how you can get much different compounds. Now, for naming these, just so you know, what's going to happen is you're going to be given the name of some elements, and you're going to be told to, well, make the compound. So what you're going to do is essentially this. You're going to come to questions, so I'm going to show you. Now they're going to state which, let's say, copper you're going to use. So here's how it would go. They would say to you, write the equation for, let's say, copper plus, let's go bromine. The point is, they have to tell you which copper you are using. So you would have to put Roman numerals, and I'm telling you in this case, we are going to use 2, which means if you look at copper, we're using the 2 plus charge. So that means it's Cu plus Br. This is 2 plus 1 minus. And that would help you determine which compound you're going to draw. Now, the point is here, everybody, when you talk about multivalent ions, you must use Roman numerals to denote, which one you're using. They also could do this to you. They could put copper 1 plus bromine. Well, with that being said, you now know which of the charges you have to use. You're using this one. And of course, that's going to change the compound. So when you have multivalent ions, you must use Roman numerals to, I guess, say communicate which ion you're using. Now, so basically, I'm going to show you now the next step in this. What they're going to do, if we go to the next page, they're going to say to you, they're going to give you a name, and they're going to say, draw the compound or create the compound. So let's everyone, if you can find tin. Tin is SN, and it's number 50, atomic number, and it has a, let's see, a 4 plus and a 2 plus. Now, what they'll say is, they'll give you a name of a compound. They will say tin, let's go with the less common charge, tin 2 bromide. And they'll say, well, okay, you have to know how to create that compound. So that means you're taking tin plus bromine or bromide, and you now know which charge you have to use. You have to use the 2 plus version. And of course, that's going to help you create your compound. Again, they could do something like, let's say you look at cobalt. They might say cobalt, there's a 3 there, cobalt 3 oxide. Well, you now know that when you create this compound, you have to use the cobalt with the 3 plus charge. That's very, very important. So, as a summary to this lesson, you know that the basics of ionic bonding haven't changed. The transferring of electrons, the ensuring that everything's balanced. It's just that when you use these ions in the transition metal area, they have multiple charges, and you must communicate which one you're using. It tells you which charge. Anyway, please be aware of that, and I hope that this lesson has helped you with some information and allows you to write these compounds properly.